All right, geometry. So we're doing this review, unit 4. Number 1 says, for the picture above, complete the triangle congruent statement, LTN, right? So I want to remind you on number 1 that order matters whenever you are naming triangles or angles. So if we have LTN, that's LTN, 2 arcs, 1 arc, 3 arc. We're going to do 2 arcs, 1 arc, 3 arcs, MQV. All right. So please remember, order matters. LTN 213, MQV 213. All right, so which of the following are valid triangle congruence methods? Okay, so on number 2, the only ones that we can use are side, 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 angle, side, angle, side, angle, 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 side, and HL. Okay, those are the good ones. The bad ones that we can't use are SSA or backwards. Okay, you don't want to spell it backwards because that's, as Miss Marrero would say, naughty, right? All right, so no SSA and no sorry, let me back that up. No AAA, okay? So angle, side, 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 angle, those that doesn't work all the time. And angle, angle, angle doesn't work at all, doesn't work all the time either, okay? Now, I'm going to put a little dot, 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 dot. HL looks like SSA, but it's for a right triangle, right? So just remembering that HL, angle, side, side, that's called hypotenuse leg, okay? So on number 2, we got angle, angle, side, angle, side, angle, side, angle, side, 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 HL. So remember, the one that looks like the bad A word and then AAA, those are not okay, all right? So let's look at number 3. So given that JKL is congruent to triangle DEF, fill in the blank. JL is a segment, and remember, order matters. So that's the first letter and the last letter. So we're going to do the first letter and the last letter. Okay, DF. So again, let me just write that down real quick. So if it's triangle JKL congruent to triangle DEF, if we're asking about JL, first and the last, then the first and the last is segment DF. Okay, so segment JL, segment DF, those are congruent. Okay. So remember, order matters, order matters, order matters. Number 4, given that JKL is congruent to DEF, same thing. Now we're talking about an angle. So once again, triangle JKL is congruent to triangle DEF, and they are asking us for angle KLJ. KLJ. Okay, so what was that? That was the second, third, and first. So we're going to do the second, third, and then first. So it's going to be EFD. Order matters. Order matters. Okay. Sound good? All right, number 5. It says, given that triangle ABC is congruent to LMK, find the measure of angle K. All right. So let's see if I can copy this over here. Hey, cool. So check it out. If we know that 1 arc is 58, then over here, 1 arc is 58. If we know 2 arcs is 74, then we know 2 arcs is 74. And you know the triangle sum theorem is that every triangle, the inside adds up to how many degrees? 180 degrees, right? You got to know that in a triangle, that the sum is 180 degrees. So if I know 2 of these angles, 58 and 74, I can add them up, 58 plus 74. And I'm going to take that number away from 180. And I'm going to get 48 degrees. Okay. So that means the missing angle, the third angle, is going to be 48 degrees. 48 degrees. All right, that's hard to see. 40. Now, what are they asking us for? What's the measure of angle K? Okay, the number value for K, well, I did it over here, 48 degrees. So again, if you know two of the angles, add them up, subtract from 180, and you'll get the third missing angle in a triangle. All right. Number 6, are these triangles congruent? If so, what justification? Let me move this up. Okay, so for number 6, all right, so whenever you have triangles touching, okay, do y'all see that right around here, they're touching. So whenever they touch, I want to put a tick mark there because obviously that side is the same on both because it's the exact same side they're touching. Okay, now on this one, all I got to think of are what are my 3 given congruent parts? Okay, so I have an angle, I have a side, and then I have a side. I have an angle, a side, and a side. And before you try to write that down, don't write it down, okay? You're not going to ever write angle, side, side, because that's a bad word, right? And I'll write it backwards, SSA, right? We won't write it the other way around. But that only works if it's a right triangle. Is this a right triangle? Yes, it is. So if it's right, then you call it HL because this is your hypotenuse that's congruent and this is your leg that's congruent. Okay? So again, if it looks like the bad A word, don't write it. If it's right, then you're going to put it as HL. Over here, it's congruent by HL. All right? If you have a right angle, you know it's a right triangle. All right? HL, if it's side-side angle with a right angle. Number 7 here. Are these triangles congruent? Now let's test what we just learned, okay? Let me copy this over. All right, so what are these? So let's see what we have congruent. So right here we have an angle, then we have sides, and then we have another side. Now if we go in order, it's going to be angle, side, side, angle, side, side. Now some of y'all are thinking, like we just did up here, you're thinking, wait a minute, that's going to be HL automatically, right? Well, again, we'll call it side-side angle. Is it a right angle? Do we have a labeled right angle? That's like this right here is not labeled as right, and that's not a right angle. In fact, there is no right angle. So this is actually not HL. Okay, I can't use SSA. I can't use it backwards. I can't use HL. Well, on number 7, if you get the bad A word, angle, side, side, and there's no right angle, that's not enough information. That's a no-go. Do not use that one. All right. All right, number 8. Are these triangles congruent? If so, what is the justification? If not enough information, state that. Okay, so once again, these are touching right here. Okay, so if they're touching, you want to label that with a tick mark. All right. So when they touch, I'm going to put that tick right here. So let's count them and let's label them. So I have side, and then I have a third side. Side, side, third side. That's what we call side, 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 SSS. And boy, howdy, there it is, side, side, side. All right. Oops. Trying to move this down. All right, cool. Number 9. Now here's something else you want to be able to label. Number 9. Let's put this down here. Now, does everyone see right here on number 9 that these two lines right around here make an X? And anytime you make an X, you create what are called vertical angles. So that means this angle and this angle are going to be congruent, okay? So anytime you see an X, those are called vertical angles. You want to label them with arcs, right? Cool. So once we have those labeled, now we can think, what do I have here? So let's start with those arcs that we just labeled. So I got angle, go along the edge, angle, go along the edge, side. So that is angle, angle, side. Angle, angle, side. So if you go along the edge, those are the three things you have. Angle, then an angle, then a side. Well, is that an answer over here? You bet it is. All right, so number 9 was angle, angle, side. Now let's test what we just did on number 10, okay? So number 10, I'm going to take that picture, put it over here. All right, so on number 10, do I have an X shape? Right there, yes, those are called vertical angles. And if they're vertical, I'm going to have to label the angles with an arc and with an arc, okay? So let's go along the edge here. I got angle, 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 angle. Now, what do I know about AAA? Is that I should say, no way. There is no AAA. That is not enough information. Do you see how AAA is not an answer choice here? Remember, you cannot do the A bad word backwards or forwards, and you can't use AAA. Those don't work, okay? All right, number 11. What information would be needed to prove that ABD, that triangle, is congruent to CBD? Okay, so what's missing here to make it HL? Now, for this to be HL, remember, HL, and let me put number 11, okay? And then we're going to use the same picture for number 12, so might as well do that too. So, one second. Number 12, we're going to use the same image, so I'm just going to put that there already. So let's look at number 11, though. Sorry, trying to zoom in here. Cool. All right, so on number 11, we want to make number 11, how do we make it HL? Like, what would we need? Well, for HL, it needs to look like angle side side, so we would need a right angle, and we would need a side right here, right? So on the other side, it would be a right angle and a side. So what do you call this point that makes two equal sides and makes right angles? That's a perpendicular bisector, right? Basically, AC and BD or DB needs to be perpendicular to make a right angle. So what we would need is this one right here, okay? So whenever you see that, that means perpendicular. That'll give you right angles, and right angles will help you, and then right angles will help you get that bisector, and that'll give you HL, all right? Number 12, what we're trying to get is SAS. SAS. All right, so what would we need to get SAS? All right, let's see here. Now, we have sides, so we either need another angle or another side. So let's see here. It says AD. Okay, and by the way, y'all know they're touching, right? So if they're touching, I can put arcs there. Cool. And then up here, what I should have done, sorry, the ones that are touching. So you have angles, this is HL. Okay, and over here, since they're touching, I have my side labeled, and if I want side angle side, side is, and then here's my side, my angle needs to be right here. So I need this angle, and I need this angle for it to be side angle side. How do you label this angle? Well, that's going to be CDB. CDB is this angle, and then ADB is this angle. So it has to be there. All right, that's how you make it side side. All right, number 13 is another one just like this. 13, let me write this one down. All right, and it says what information would be needed to prove ABD is congruent to CBD by side, side, side. So remember, they're touching. So we have this already labeled. They're touching right here. And then AB and BC, I would need that third side to be congruent. AB and CB. So that would make it side, side, side. So I would need AB congruent to CB, just like that. All right. Cool. Let's talk about number 14. Find the value of x in degrees. Now, if this is our picture that we're using, okay, we have to remember the isosceles triangle theorem. So if two sides are equal, that means the opposite two angles are congruent, right? So if this is 75, then this right here is also going to be 75. Okay, so remember, two equal sides means two equal angles. And if I know both of these are 75, can't I figure out x? Because they always add up to 180 inside of a triangle, right? So 75 plus, oh, let's try that again. 75 plus 75 plus, and that third is x missing equals 180. Basically what you do is you add up your 75s. I got 150. My last step to get rid of that 150 is to subtract. And x gives me 30 degrees. So again, two equal sides means two equal angles. Solve it for x. All right. Number 15. Let's see if this might be a little bit similar. One's similar, but a little different. So check it out. If this and this are congruent, if that's x, that means that's also going to be x. Okay. So this time we have two x's, but don't fear, we're going to set it up the same way. 102 plus x equals 180. So I'm going to take that and I'm going to solve it. Now, here's the deal. X and x, 1x plus 1x gives me how many x? 2x. So I'm going to bring down 102, and then we'll bring down equals 180. Now this is a two-step equation I need to solve, so I'm going to get rid of this loner 102 by subtraction. Minus 102, 2x equals 78. And then my last step to get rid of that 2 is to divide. So x equals 39. All right. So over here, I can put 39. Both x values would be 39. It would add up to 180 in this original triangle up here. Okay. Let's try it with number 16. All right. So with 16, we're going to look for angle C, and then with 17, we're going to look for angle A. So let's put this in here twice. We got 16, and then we're going to have 17. So for 16, now here's the deal. Y'all know a linear pair, a straight line, adds up to 180 degrees, right? So if this one's 114, 180 minus 114 gives me 66. So that means this little angle is going to be 66. So anytime you have an exterior angle, you know you can figure out the interior adjacent angle next to it by subtracting from 180. Okay. And once again, I got an isosceles triangle. So if that's 66, then up here, that's also going to be 66. Now, that is the answer for number 16 here. Okay, one second. So again, I just figured out C is 66, and that's what they're asking me on number 16. So C is 66. Now, I'm going to use that information to fill in on number 17. Okay, let's move this down a little bit. So we figured out already, because it's the same picture, that this is 66, and this is 66. But now I'm looking for angle what? I'm looking for angle A. Now we've already done this, but the triangle sum theorem says that it adds up to 180, right? We know that already? So I'm going to look for this. We'll call it x. So x plus 66 plus 66 equals 180. And I do apologize for the terrible handwriting because I am having to write on a laptop screen. It's tough. So anyways, 66 plus 66 is 132. All right, so I brought down the x, I brought down the equals 180, and I get rid of the plus 132 with a subtraction, minus 132. So x equals, and when I subtract, I get 48 degrees. So I can put that over here on number 17, 48 degrees. All right. Now, these last ones are a throwback to Algebra 1, okay? Talk about it. The following lines parallel, perpendicular, are neither, okay? Now, if you have 1/3 x minus 6, and if you have 3x plus 1/6, are those parallel, perpendicular, or neither, okay? So let me go off to the side. Actually, there we go, cool. All right, so let's make a little note off to the side here. So parallel have the same slope, okay? Now, y'all remember y equals mx plus b. M is the slope, right? Okay, so parallel have the same slope, but perpendicular have opposite reciprocal slope. Opposite means you change the plus minus sign. Reciprocal means you flip it, okay? So like for example, okay, if I have 1/2, it's a positive slope is now going to be a negative slope, and then I switcheroo right there. So if I take the reciprocal of 1/2, I get -2/1. Okay. If I have -5, what's the reciprocal? Put it over 1. Change that negative sign to a positive, or don't put any negative sign, and then you flip it, right? So it's 1/5. Those are two examples of opposite reciprocal slopes. That's what it means to be perpendicular. The slope has to flip over and change the sign. Now you tell me, look at number 18. If I have 1/3 and the number 3, which is over 1, are those opposite reciprocal slopes? Well, obviously they flipped, right? But did the sign change? This is positive and this is positive. So that is not opposite reciprocal. That is not perpendicular. So if it's not perpendicular and if they're not the exact same slope, then guess what? That's a neither situation. All right. It's 2 more. Number 19. Are the following parallel, perpendicular, or neither? Okay. So y equals 7. 1 second. Might be some announcements in the background, but y equals 7, and then y equals -1/7. Now this looks like it could be perpendicular, okay? But I want you to know when y equals a number, that is a horizontal line. And this one is also a horizontal line. If there's no x, it is horizontal. Okay? So if this is a horizontal line and a horizontal line, those are parallel. Parallel. Okay? And then last but not least, number 20. This one might be a little bit challenging, but we can do it. So we have this in the form of point slope form. Y'all remember that from algebra 1? So what we want to do first is solve this thing for y. So let's solve this for y. If it's not in y equals, you need to solve it for y. So first thing I'm going to do is distribute the 2/3. 2/3 times x is 2/3 x. 2/3 times -7, -14/3. All right. And then to solve for y, I need to get rid of this loner -4 by adding 4 to both sides. Now I'm doing this a little fast, that you could do it with your calculator as well. Okay. So I end up with, 4 is, 16/4. So if you have -14/3 plus 16/4, then you get -2/3. Actually, you get +2/3. My bad. All right. All right, so that's my first equation. What was my second equation? Y equals -3/2x plus 5. Now let's look at these slopes. 2/3, -3/2. Now, did the sign change? Yes, it did. Did it flip? Yes, it did. So when you have those two changes, that's what we call perpendicular. All right. So that'll be perpendicular. That's good for your review. Hit submit. All right. And your test will be next class, and it'll be very similar to this. All right.